Oh, the roadie or what?
No, he was just
Chilling?
yeah.
You guys gonna use this? Fine.
Where they can see what's going on.
Kind of works out pretty good.
They're all good. Right. Plus, I just got back, I didn't have time to get these, track of which, look at that. Europe is much further advanced. Are you able to hear me or could I say good opportunity? I'm ready to take that. I'm ready to do So the HFP. Well, that's why I was it's like it almost feels.
You need a shorter one?
Yeah, it's definitely not the big ones like. I'll check.
How is this? That's shredded or is
That's just a whole lot in there. It's just
oh,
it's sitting on pins right now, and this one's holding it.
Switch from.
So these pins are like so long, and that's just to get it away from the shaft still.
No. Cold storage. The end room goes back there.
man, this one has a ball.
Yeah.
Yeah. Yeah, you were probably confused as hell when I was telling you about these.
Yeah.
I was like, look at the new one, just take them off the new one. Yeah, anytime I do one, usually I'll pull this back and then I just tighten and I'll leave them. So then if it has to come off later, it's already there.
Yeah.
But I also have the luxury of getting more.
So.
I think whoever put it on last time, I think that's what they went off by saying that we leave them on there.
Yeah, you always want to back them out of that groove, otherwise you're gonna.
But then I also, when I was trying to take it out, I put these in and then loosen up the set screw.
Right.
Trying to put it out.
But you don't pull all of them. There's this one and this one we don't touch.
Oh, really?
Yeah, usually there's silicone in the hole.
Yeah, yeah.
No, like don't mess with those ones. What that does is, so this is one complete unit. You know how normally when you push a shaft seal in, you can feel it like get tension on it.
You know what?
It's all preset, and that's what this is doing. So that's holding it in place. You tighten the set screws and you pull these out and it holds it there. If you were to take these out right now, that's gonna pop out.
Push out.
Yeah, and then it's technically
Right,
messed up.
right.
If you got it to seal again, you got it.
And those are rebuildable or you send them back to,
No, they're not.
oh?
So.
No,
I feel some sarcasm.
they gotta tear them all back apart. But it's. They're very expensive. I don't. If generally if one comes in for rebuild, it wasn't quoted with one, and then I tell them, hey, they're like 12 grand. What? Yeah, let's just buy a new cover and a seal gland and put it back to it.
But I felt like it just don't last as long.
These last usually longer.
Oh, really?
They're considered a heavy duty. They're aftermarket, they're not factory. Generally, they take a little more abuse because it's one complete sealed unit. So if if you had or they seal in different areas too. So it's just like going from a multi-spring to a bellows seal or a boss seal. They all seal in a little different area. So if you got a scratch, you can get away with switching to a different type of seal and sometimes fit.
Sure, well, make sure ROI.
But these aren't the ones you want to
That's
have.
what I need, CO2 capital projects.
Yeah, you'll take a job pretty fast.
Utility money and, I don't know.
Get a lot of
just
them
one thing. Brings us back,
Items.
you know, you know.
They're like, where'd you guys get that compressor from? I was like, oh, you don't recognize it?
Right.
So pull it from your place. And you guys don't
There's a white.
They're from Concord?
Yeah, they're white.
That's from Concord?
No, they're like that.
No,
Green gray. Yeah, they're more silver or some shit.
Like, my,
Yeah.
The black one, right? Yeah.
I was in town the day I found out. It's-
but they could be.
Yeah.
They could have been.
For all of that, and I was at the DOT, and I'm driving away, my friend sent me a text, like, hey, you're not doing it, shut down. I was like,
One of my problems
just made it, cause running the whole hour, I was staring at it.
for a while. Was Jason's phone down. Check in play. In play.
Oh, yeah.
Check it. I think it's in the 20,000, 30,000. Yeah, it's.
Which is crazy, cause I said.
And they haven't died. I asked Jason, I said, what'd you guys do? Well, did you clean it up? Clean this back up?
Yeah, so I do.
I don't know, did you balance it? So you just remove the shit ton of metal off this maniac valve.
Yeah, last time I was there, Steve, basically made us do all the work, because I was gonna do a PMs, and I didn't have anything else for me, so he's like.
Yeah, so I never even had that, but I don't know. Got in there, he's like, hey, you got a job, yes, America, you got a choice, one that I give it to Jason.
Well,
it's wanting to get screwed.
That guy doesn't, they make us fucking pull it. That guy, we put on a pallet plan. We had to set up his fucking gantries and then take it down for him, put it back in his van. And then he takes the compressor, and he goes, comes back, has those fucking installed, he sets the gantry back. And then calibrating, he does a line, pull it off.
No, that's things.
Well, look what he did his last time.
The end of.
Well, I told him,
Look at solar.
well, now it's like,
He started up.
That's pretty much it. I don't
Looked it up. Pull it.
oh, that's when they pulled the one out of that.
But I go as far as, yeah, come on, all the way to Clark.
Yeah.
And then Walla Walla.
I told him, I was like, you don't get it good
I
if
got
you're
it.
doing it on site, just because you're not.
Maybe 36.
Every compressor we bring in, your rotors all get down.
It's cool. It's like a little small area for like the insurance inspectors, like they used to go to Tyson. Starting to find out those guys have like.
Very good.
And you know, they're working for a month, so they only got some. We just go forever.
I got
I appreciate it. The state owns the numbers on them and that's their. Such an accumulator at the top, right up at the roof, and then they put the data pad 2 inches from the roof, and then like up the motor. Way some places that are and stuff, and you're looking to a place today, they had a tank in 1952. And the compressor discharged into it, the compressor also had a tank, so it was a storage tank. But the way it was set up, it was just really weird. It was like being piping up and then the pipe went down. And you were like, I was like, there's the yeah, how you
You
make
got, I'm pretty good. I was at Tyson the other day.
Really?
Yeah.
And I heard, yeah, Luke was telling me they lost a bunch of bridges and then like the new L bank they put in, it's not maintaining the section now, like it's always too high. The main, it has like a 6-inch section with a fan cost control, but then it also just has a big old equalizing pipe straight to suction down at the evaporator, so that's not really controlled. I'm like, how are you getting, so we got something going on. Yeah, that company.
Looks like he's.
Yeah, I've been trying to help you. It's kind of like, hey man, this place is kind of good.
A little bit heavier than the original.
If they were here, they'd more about it in the crowd. Like, they probably just wanted to talk about that. Yeah, it's like the game maker. I always think it's like, I hope I should.
No. Yeah. One of them. Right, and the other one side. Or we. If my top on the place, places are upset on one arm, and then let's walk it like we all day. Make sure most often, that way when we- So we did like- Yeah. By the end of October. Yeah, and you're, what border holds, everything I get, you got one that's full, or shape or whatever. Well, it's pretty that one. But it's gonna be something that's ours, take that back to shop, rebuild it, and show that. I got both the placing, taking, and the place are, and all of that behind it. No, I think we got more, we got like more. Yeah, the little ones that they can ship here, they'll get here. Pretty happy. So anything that's everyone, like all everything. They got. We didn't realize. Yeah. That's a big. So where the top of the hill sit down, right, and then you got four top. The top down here, you got four top and tail. Right, 40 top. Yeah. And then once we have all of those, then we're gonna demolish them.
Oh, yes.
Get out of the top. That's your plan. Next year.
Well,
Exactly. You know, like, well, maybe. Safety thing. Oh.
Yeah, so.
Yeah. Yeah. They got, I mean, when they're running those lines outside, whoever's running their meetings, whoever's running the bin, pick that one up, get it put in, get back, and like pushing that line for you. It's overkill.
That's why this is.
I'm pretty sure it's. I'll say they are some. Put the. Yeah. So. Basically, one of the black hole. They said you guys. No, we're waiting on two right now. And then, we're also using. Well, this is. I care because, one by slow rate. Yeah, but then rush it up and make like. I care by itself. Then it comes down to all the time. I'm here and so. Can't wait to control. Came down. Doesn't have to do with. I'm here. He's got a system, discharge pressure, not being. Yeah. Every time we see
Yeah, no, really.
so.
I'm like, fuck pages on something you. It went around you there, so went on stuff and went back to the all the way down. What the hell?
Hey, and then, when you get your email, you gotta be like.
Yeah, I need to, everything.
That's why I just used my first.
Yeah, I'm gonna take my personal.
There's one, that's one. That's one thing, you got three or five stuff.
It's kind of cool, but, you know, but it's.
Yeah.
It's like everything else.
I'm not.
If you're finding a new email, then it comes down to the bottom line. All right, so yeah, we need to make sure that we get these set up. It's like all the stuff goes downhill. Pretty much. Yeah, this, two texts out there, good on it, yeah.
How you doing, Shane? Hey, how you doing? Andy?
Yeah, we're start setting.
It started?
Alright, everybody, taking car now, I'm running a little bit behind. We got nothing. We got nothing more here at Kemper Northwest. We're gonna do a screw compressor tear down. Feel free to ask questions as we go along, but be mindful, we are recording live, so we're trying to keep it down
Okay.
or keep it professional.
All right, guys. So yeah, I'm with Kemper. This is just your basic MyCom. It's not, it is a variable. It's not hydraulic, manual. A lot, as far as the components, there are a lot of similar components across the board, all the compressors. So like I said, if you have questions, when you got a brick or something, you guys want to know how something works, that's fine. A lot of it will all correspond. This one does have a cartridge seal, so there's a few components that won't be in this one. Again, aftermarket, they are heavy duty seal. Unfortunately, I can't be on that side of the table to do some of this. But I will.
You lovely assistant.
Sure, Tony. So I've already disassembled a lot of this stuff just to make it time efficient wise. But obviously there's just a lot of bolts. Manual variable nut. I left my box of bolts outside. This is the rod where you adjust for your slide stop. Normally, most of the plants aren't messing with this. Can be done on startup. Get this up first. Flat screwdriver. It's in my bag right here, Tony. Other side. That one. Perfect. And again, I've already taken the O-rings and stuff off a lot of this stuff, so. Here's the cartridge seal. Again, normally there'd be a bearing gland right, or a seal gland right here where carbon would be. This one, again, doesn't have it. Pull that.
That's another question.
Can you explain the different types of seal that we normally see?
Oh, man. So the older Mycoms just generally ran probably the typical double seal everyone's seen. It's an FES model, probably had a bellows seal. A lot of the newer Mycoms, there's, a Boss seal, BBSE seal. They're just a single seal. A lot of those there'll be a lip seal. They call it a sleeve that sits on there that the lip seal rides on. It basically seals that chamber. A lot of guys didn't like them. You can convert them back to a double seal. You got to change a seal gland. If you're not real familiar with a lot of those, it'd be really hard for you to just pull it out and know what it is if you don't see them all the time. I won't say one's better than another, but they all do seal in a different spot. So if you get a scratch in the shaft seal area, you can convert from, say, a double seal. You could try a bellows seal depending on, because they're not moving the O-ring a lot, but sometimes it's enough to get it to seal. Again, if you do have that's where like a cartridge seal would come into. It's all just the only way you're going to fix that is either metal spray it or sleeve it. And you're not going to do that in place. So those are just options. If you notice, generally it'll get scratched if a guy didn't get the set screw out far enough and they pulled it out, it's going to scratch the seal area no matter what. And then you can attempt to clean it up, but 9 times out of 10, it's going to leak. It's bearing blank, it's bearing covers.
So no more graphite pregnant seals like what was on compressors 30 years ago.
Not necessarily. I mean, everything's pretty much sealing on an O-ring. So, but the carbon faces, if you scratch one of those, a lot of that's going to come from dirty oil. That's the biggest, when your shaft seal is leaking, it's going to be contamination 90% of the time. And that's just comes from any seal I've pulled that I've had to have warranted, and they go, oh, it's contamination, no warranty. I think they just tell me that half. This bearing cover does have, it sits on dowel pins. If you're ever removing one, it's probably going to be stuck at first. There are pusher holes to push off. Again, this one's a variable, so there's going to be a Teflon washer behind here. A regular fixed machine isn't going to have this. It's just going to look like a blank cover. You might have to pry it off a little bit shortly. There should be a little pry bar in there. Right. Nope. I can see it. There's just the background. Do that one and give it back to you. You are removing this in the field, you want to be mindful of the shaft seal. Sleeve you can put on there. There's the Teflon seal. It's going to sit right here. That's for the slide stop. A lot of times if you're seeing those nuts right here and you're getting oil dripping out, it's going to be, there's some O-rings in there, but generally it's that Teflon from the slide stop not being locked up right. It ends up hammering those and it just disintegrates them. Not exact. I mean, here's another thing you'll see too. Generally, if the thrust bearings have failed, there'll be a bunch of metal up in here and on this shelf. This one's not anything uncommon. It's actually fairly clean considering it's been kind of open up for a while. We can probably pick that off here. Somebody set it on the same thing for us. We'll just set it up. Here, you want to pick it off. It's not super. All right, let's set. So here's where all, basically the thrust bearings are gonna sit. Again, I've taken all this loose. There's lock washers holding everything. It's just this is what locks up the outer race of the thrust bearings to keep those from spinning.
What are these, Justin? It's like a,
It's
oh,
just
that's a lock washer.
Yeah,
Okay.
it's what we consider a lock washer. Some of the newer machines that are running a Bellevue washer right here instead of these, I tend to get rid of those and go back to the old school, tried and true. You know, it's bent over, it can't loosen.
Okay.
My company swears that you can go either way, but I just stick to those. So this is gonna be your nut that locks up your thrust bearings on the inner race.
So at this point, when you're taking this part, what would you be looking out for?
Generally, what I'm looking at right now, when I'm taking one apart, I'm looking metal. I'm seeing metal. Obviously, this is generally where it's coming from, the bearings. If you're getting, if I see a large amount of metal on that bearing shelf, generally it's going to be an indication that the bearings have failed and the rotor's contacted one of the castings. So,
Those are just spatial washers.
yeah, they're just a washer that helps lock everything. Basically keeps your lock washer from making contact right here.
That's the bearing.
So. Sometimes these always top. So on my toms, similar to a lot of other machines, these bearings are opposed to each other. Basically to lock up the axial movement and the compressor holding it in place. And these typically, when I'm tearing one down, we're gonna break these open and inspect the thrust bearings themselves, the races, the balls, cages. Just so we know if something's going on, if there's contamination.
We're checking in.
When you guys are checking in play, basically, this is what's setting the clearance. This washer right here.
So we're trying to see how much wear.
So
there is in that
basically, you're
washer.
checking the wear in the bearing. When you guys are doing level A's, in play checks, that's what you're checking.
Where
It's-
would that, where be? Like
It'd be
that?
inside the bearing as far as the balls to the races. That's where that movement's coming from.
Oh, okay, that's where our looseness would be between the ball.
Are you replacing thrust bearings every time you break the end of it open?
If I'm, as far as if I pull a machine open, generally at that point, I'd be replacing them. I mean, you can pull them down to inspect them. But realistically, you can do that within, if you're doing in play. You can't check the female with doing that. You can just check the male. The male's taking most of the load. So
That's.
you
that's where your
generally,
So
catch.
What's
if
that?
you're
That's
just,
where your
if you're
cat.
this far in, you're replacing it.
yeah, I'm not gonna, cause like, you could visually look at this, you could roll it around, you can look at the balls, you can look at the race somewhat. But you're not getting a really clear view without breaking it. And obviously then it ain't going in. Again, this is what's setting your clearance. This spacer, when you buy them new, they're set at a pre-thickness. You machine them down to get your clearance off the discharge head. Basically, that's going to be the end of the rotor to this discharge casting. That's that gap. That's what this is setting. That's not something typically you would ever adjust in the field for no particular reason. If you're putting bearings in, yeah, you're gonna have to check it. You might have to adjust accordingly. I do find running the factory bearings, if it comes in at 3,000s, when I put it back together, it tends to be, 3,000s for an example. It's not all of a sudden you got 12. It tends to stay the same. And when we rebuild them, it's all factory. I'm not putting aftermarket bearings in them, sticking them with the OE tried and true. This one, I haven't found anything damaging yet, which is good. Again, these bearings are matched. You buy them from Micom, there's an arrow on them on this race, so that shows you how they go in. So you kind of can't really mess it up. It's really hard to see, but you guys can take a look at that when you come out. It's right here. That means goes in.
Defect, I don't see anything.
Again, a lot of times you won't
See it.
see it like this. You're gonna have to break it.
Hey, Dustin, at this point of the tear down, at what point do you see where you're saying this compressor's trash?
You can see it, I mean, take this
So a
off.
lot of times it's when I
Some
pull
metal.
that off, if I'm seeing a bunch of
Bit of
metal
metal
right
in
there,
there.
and that doesn't necessarily mean it's garbage. It just means, generally, that means one of these bearings has failed. That's where you're gonna see a lot of the metal from.
So if I have a pretty good maintenance program where I'm doing regular vibration analysis on both of those shafts. How often can I catch a failure before I gotta take the compressor out and send it to the shop?
Vibe should.
You know, a lot of vibration analysis, oil sampling is what all the manufacturers are gearing toward. They're not telling you 30,000-40,000 hours anymore because there's so many variables that come into play. How often is that compressor started, stopped? You know, is it running fully loaded, moderately loaded? So vibration analysis and oil sampling is your best bet. And just because you took a vibration analysis today doesn't mean it can't fail tomorrow.
Right.
It's just the likelihood of catching it early. I mean, a small defect in one of these bearings will cascade fairly fast. I mean, once it starts, it's just going to keep going.
So are you getting any compressors that come into the shop for rebuild where they actually have that information that they give you that said, this is the start and stops, this is the full load, this is the slide valve
No.
was for those, that can be, because we know that's where the industry's headed, right? With AI
Sure.
and condition monitoring, you know, and SCADA systems, you know, you can plug all of that stuff, you know, into a computer and it can tell you, it can give you a printout. This is what happened to my machine for the last 12 months. So
A lot of
I
times,
think that's coming, it's just not here yet.
yeah, I was gonna say a lot of times that's true, but one compressor to the other, it might not hold true with, hey, that one at 48,000 hours was starting to fail, so we're gonna do that one. That one over there might run 80, you never know. I have seen compressors come in with 80,000 hours that should have been rebuilt at 50, and then they wondered why it was making noise and not doing what it's supposed to.
Some of this simple as hangers, taking the weight off the suction teeth. You know, where all the weight is sitting on that suction teeth and twists that machine over time and it will damage it.
Yeah, pipe strain's big too. I mean, a lot of guys don't think about that as far as the structure that the machines are on. You think, oh, that's a big heavy cast machine that weight's not. It does. It will twist things, and that's where, like say, vibration analysis should pick up on that, where you're going to see structural looseness, things like that. So from this point, I'll usually go over to the other side, get that apart so I can get this rod out before I can take this head off.
I'll bring this over.
I don't need that. So obviously you got your tensiometer.
You guys want to come over here and take a slide out?
So. Yeah, it's taking over here. And the biggest thing I do see a lot of times when these come in is my com, they don't have a pivot on the spindle where it's set where it's supposed to be. And for whatever reason, maybe when it got calibrated, they didn't have it fully loaded or fully unloaded when it started. And what I'll do, basically I'll put that set through where it's not supposed to be. Like in this case, this one's clear over here, which if this machine is unloaded, I unloaded it, and the needle's clear over here on high. So it tells me something was going on here that somebody took it apart. It was messy. No? And again, I removed O-rings off this knee for another this assembly. So this is gonna be your spindle. This is gonna tell you where it's loaded at. There's a pin right here that drives it. So if your machine's loading and unloading a lot, that pin gets worn and it will break. So then the machine, obviously it'll still load and unload, but you know, your potentiometer is not gonna pick it up. With your unloaded piston. Sometimes they come out easy, sometimes they don't. So this one, they have a cap seal that basically protects the O-ring where it rides on the cylinder here. Hydraulic pressure oil pushing that piston forward and backwards to load and unload the machine.
That's another Teflon seal there.
Yeah, it's just a cap seal protecting.
And then, what's the O-rings, what's the material of the O-ring inside?
The O-rings,
Yeah.
they're usually HMDR. So being this one, it has a spacer in it. I found that a lot of the components are interchangeable. There's a space in there, so the unloader rod can't go back into it, there's no room for it.
They just want to go get a flashlight, much higher can operate. You become higher, don't you? Oh. Probably, yeah. Pretty good.
So on a normal rebuild, we're inspecting this board, making sure it's not all chewed up. The wear that's on this one, I'm gonna guess at some point that cap seal got wore out and it allows that piston to drag. They're gonna get these little scoring in here. It's not terrible.
Yeah, again,
Oh, yeah.
that would be from piston ring.
Yeah. I wouldn't be surprised. Yeah, you can see right here. You can see it. It's not terrible. It's still a lot of stuff, smooth it out.
So what happens if you get some years?
It'll get stuck.
I've seen a lot of these come in for rebuild where that cap feels wore down and the O-ring's exposed. There's no complaints. Generally, the complaint we're gonna get is gonna come from these O-rings back here.
Sometimes you have to pick them stuck, I've seen that, or you can have oil rub. That's
On its own.
because there's some different on the side.
This particular part right here, you have to be careful with on the older machines. They are, when I get it out, elaborate a little bit on that. Always. A bit tighter than you think they should be. Another thing on this pin that drives that spindle, it only goes in and out one way. You don't ever push it down, it's got knobs in it, and it's a press fit, so if you keep breaking that pin, eventually, you're gonna wallow that hole out enough that it's gonna have to be repaired, it's not gonna hold it anymore.
Then you have
And then the compressor's gotta be disassembled to do that.
How long does the tear down take typically?
A lot of it varies, like I said, I mean, a lot of it depends on how tight the bolts are, a lot of times they've been painted, quite a few times, so that kind of leads to having to clear out all the holes in order to get the bolts out. The initial tear down is really not, that intensive as far as time wise goes. It's a lot of it's cleaning the parts, inspecting parts, measuring parts. That's where you get into a lot of the time. On a lot of the older machines, for the oil injection, like the fixed VI that come in here, the oil would pass through there, runs through this rod, and it'll be bigger, and there's only a hole on one side, which has to face that oil injection port. If you put it in wrong, you're gonna have problems. The newer ones, obviously this one's a variable, so it doesn't have it, but on the newer ones, they actually put holes on both sides, so you can't really mess that up. From here, I would need to go to your balance piston, and the snap ring is gonna hold that on. There's a big snap ring here that's gonna hold the balance piston sleeve on. And what that's doing, that's assisting the thrust bearings with the load axially on the actual male rotor, holding it in place. As that slide valve loads, it changes the load force on that rotor as far as which way it wants to go. A lot of times you can actually, when I'm disassembling this, I won't mess with the snap ring right now, but on this one, I don't think it's coming out.
No problem.
If you guys want to look on this side, the female, it's visible right now.
More?
My contact. Here, real sleeve bearings, what are lower bearings? Where these sleeves are placed. I will say I do see a lot more of the lower bearings that fail as far as the sleeves generally get wiped from lack of lubrication. That can come from liquid sludge will do that, or wipe the oil away. And then the rotor dragged on and wipes them. I have not had this one apart to know if these ones are wiped yet, so I have not actually taken the suction head off. You guys got any questions right now?
So how much liquid does it take to really wipe down?
I just wanna let them see it well.
It doesn't necessarily take a lot.
There's a lot of people
Usually
that-
when the sleeve is pretty wiped.
So when you say not a lot, does that mean,
It could be
you know,
starved, you know, not running the appropriate oil pressure, strainer got plugged, stuff like that, and so definitely prematurely.
any combination of upsets in the system
Correct.
related to oil, you know, pressure problems, you know, just exasperates it.
Yeah. It's probably me.
So pay attention to those spurious oil pressure alarms you get, right?
Yeah, it does make a big difference. You figure that
Yeah.
machine's turning it, you know, 3,600 RPM, and it relies on that for cooling and lubrication, which two of those things make your bearings last longer.
So all the bearings that we took out on the east side, are those all considered good main?
Those are thrust bearings in this.
Guess it's intermission right now.
No plans for snapper and pliers. I can probably get it out with another tool, but. Yeah. Like I said, there's other ways of doing it. Yeah, it hurts. It's. Oh, it'll break. I got one. Maybe. I don't know what you did. What opening? Yeah.
Oh, I think.
No, there it is. Not very dirty. Yeah. No. I know, we'll be bringing it back. You sent it out. You sent it back? Well, we told them we needed a boarding section. Yeah, this isn't one you want. So that's what we're gonna begin. We're gonna get them for all. They clean my. Yeah. Easy money. Little bit. Big T, 30 minutes ago. Huh? It's about a big T. Okay. I said this is. I know. Yeah, this is. No, no.
Saying you're lying.
Really big person.
Baby, see you plus, you're right. There.
I think we gotta set a snapper and fires in that.
That'd be a really big.
I think the right tool for the job. How often have we all been there?
Well, in my shop. I turn around there. Don't touch that, Gary.
Hey, like this, Gary? You don't have one of these.
We don't have one of those. We don't have one of those.
Now the little ones. We can't use them anymore.
Like pressure.
Yeah, I'm told. We just need to move
Oh, wow, we didn't expect this. That was their last one, so it was real awkward. It was funny, they came in. When you laugh, I was going, all right. And then, I think Joe came in, Don came in, we were walking, I think we were looking at the subfloor. They were just going, they were in that. Yeah, a little bit. But it is what it is. Yeah. Well, they brought the film tech, and I guess the guy from Kennewick, the nephew, the guy that was so it was kind of fun. Yeah, it was kind of unique. You got potential, oh yeah. Those are all. Okay. Yeah. That will work. And I can ask you. We'll take
This one is for.
We have to like, put a lot of force in.
Yeah, you have to keep holding on it. Yeah. If you have the right snack.
Yeah, like a big. There.
Careful, there you don't even.
I think if I can just twist these.
Hello? What's up? Yeah, everyone does it. Well. All that's. Oh, so.
Yeah.
And that's.
Wood seal? You know, you take that whole. There's so much more room here. So which one of this? Watch out.
Guys.
Next week.
There you go. Nice.
Yeah, these things-
Push your balance piston. Leave right here, this clearance is what that seal right on. When we get these in, we're usually inspecting them for galling.
Yeah, I got it.
Got a pretty big ding in it. Not uncommon. It's not terrible again. Parts that are normally replaced. So this, it is removable. There's a grub screw right here. At this point, I normally don't remove it. We're getting that grub screw out, rotor's in the way. I usually wait till the head's off. You can remove it right now. It's not terribly hard. Just it's just a grub. The anti-rotation. But the problem in face generally right here, once you pull this out, you can't really get behind it. I can pull it out. I normally, like I said, leave it. So it's on the way. Yeah, we can pull its head off.
You don't have to. Make sure it has the weight capacity, or they're gonna send it home. I need one.
Okay, buy one.
No, I gotta one. What? I need one for the project they want me to do.
Yeah,
So
good luck in finding one.
I was just gonna say.
this head has lineup pins, but I've already knocked back for easy getting it off. Those pins are basically what set where the motors need to be. When you're assembling them, you're always gonna make sure those are in before the bolts get tightened.
There's room.
Yeah, that came off.
So. Turn this to the camera so you can see it. So here's where your sleeve bearings are, and this is where I'm gonna be looking only for any sort of wiping right here. These ones, there's a little bit of wiping on this side.
What are you referring to with white?
I'll show you in this one. It's got minor, it's not. So right here, you can see there's some bearing material that's been rolled over. That's what I'm referring to as wiping. Like I said, it's pretty minor in this one. It's, way worse. The female doesn't have any. Yeah, those that are normally changed when we're rebuilding these.
So, yeah, right.
Yeah, it's a rub. But you can see where it's wiped the material down, the rotor's turning. A lot of times you might see that it's like a battle material
Is that the same thing I'm seeing on this side?
on this one.
Oh, no, on the male side, on this end of it, inside there, right
Yeah,
there?
right there.
That's that,
Yeah.
okay.
That's what you're looking at.
You wanna briefly explain the difference between the male and female side?
As far as the male, female, the male is gonna be the driven side. It drives the female. That's. Male's always beside the shaft seals on, it always has the balance piston. You get into some of the older bricks, they will have balance pistons on both the male and female. The newer ones pretty much all just have it on the male. They must have found they can just do the same thing without having to put that part in there. These two sleeve bearings seal on O-rings, oil's injected through here. That's where there's holes in here where it lubricates. That's where I say your clean oil, that kind of stuff matters because it's not a very big hole either. So when you starve it for oil and it's not getting what it needs, that can be a result of that. As far as the varnish in here, that's not uncommon at all. We see it pretty much with about every compressor that comes apart. You're gonna have that varnish from the oil heat. That's, I mean, like, nothing too out of the ordinary. Another thing we will generally see if the compressor did fail or had an issue, you will also get metal right here that'll collect. Another common thing I do see is when we knock these sleeve bearings out, especially on my com, I will see it looks like plastic, almost like a hard plastic, and what it generally comes from is the glue on the oil filter. The caps are on. You'll get a little bit of that that'll come off, just, and it always seems to deposit under these sleeves. There's a little galley in between there that will catch. Sometimes you'll see a piece that might be protruding out of one of the oil holes. I have seen compressors come in where these holes are packed full of O-rings from the oil filter. When guys change it, they leave the O-ring and it gets blown out or whatever. It always ends up packed in these holes.
Dustin, the machine that, one of the warehouses had a problem with oil pressure. Can you describe that on this?
So on that particular machine that Dan's referring to, see if I can.
Machine would, you turn the oil pump on, machine off, and it would produce the oil pressure that was required. 45 PSI.
So the one advantage of the
started it, oil pressure would drop out.
So that's where I was saying the clearance is right here. The balance piston's in, sleeves there. That particular machine, the clearance right here got too big, which again can come from excessive contamination. You get something in there, the balance piston's gonna pick it up and just drag it around that sleeve. And when that happens, that clearance becomes increased and you lose the oil pressure from that. And that one, I think it was losing oil pressure when it loaded. Or right, Tony says right when it started. So, but that's what we found was the balance piston sleeve was worn way excessive. I mean, that clearance in there's, it's not much. If you don't get it right, you can drop in it. Right now, this one's, it's not terribly worn. You guys can feel that if you want your hands dirty, but this isn't uncommon when we take them apart. This is fairly common. It's when they generally, when we're taking them apart, we'll look at that and we'll see if there's a huge gap, but this stuff's replaced when we rebuild them anyway. But it's something we know generally, hey, balance piston sleeve had excessive wear in it, which generally contamination, like I said. We can get this out of the way. I'm gonna set it down.
Now that we.
So during a compressor rebuild, how many of the consumable parts do you actually say this passes inspection, I'm gonna reinstall it?
A lot of times, I mean, the tolerance in this is very tight. I replace this doesn't matter if it's fine or anything, it's not worth it. Especially if it's got anywhere, you guys are looking for longevity in your machine, you don't want me to pay attention to it, it's barely intolerant, and you don't want me to do that. Because then in a year, when you have an issue, you're like, this is useless. So that's the thing. You know, like I said, if it's a normal wear item, it's getting, you get exceptions with like spindle. Nikon, very rare that I see a Nikon where the spindle is thrown out. Most of them are thread. I think it's just difference in material we're bringing out of. That would be something like if I said it was flexible, I would be generally make an interest to it. A lot of times you can smooth it out if it did have a hard spot on it, it'll be fine. But if that comes up, then I would say, hey, I would recommend you do this based on what I'm seeing. And kind of go from there. Same thing, like if I'm running into a bunch of excessive gouging in this piston, between the piston and cylinder, same thing, we're gonna bring that to your attention and tell you, hey, we recommend you replace it. Ultimately, it's your machine. I'm gonna do what you tell me, but I'm gonna give you my recommendation on what should be done with it.
With this machine open, you described half of the amount of the machine.
So from this angle, when you're looking at the C rotor just spinning this way, all the compression is gonna take place down here in the bottom. That's where the slide is at. This is the suction. Yeah, and it gets misconstrued, especially when you get into a different configuration, like some of the small Kobe's that are vertical. You know, the male sits on top of the female. In that case, you're always gonna look at where the slide valve's at. If it's on that side, you gotta take into account which way it's gonna rotate for that valve to be doing the compression. And once we get these rotors off, it's gonna be a little tricky. Just the nature of what we have. You'll be able to see the suction side of the compressor versus the discharge. Will make it a little more sense. You will hold the unloader rod for me. So a lot of the newer Micons don't have these two bolts here. The pressure wrench behind you. Basically, what this plate's doing is it's stopping if somebody's unloading or changing the variable in it. It stops you from being able to drop the slide stop off. Just a big watch, so to speak. All right, Tony, stay away.
Left? My left or your left?
He's spinning that off the rotors right now.
He's spinning that off the slide stop right now. So when you're changing your VI in your machine, you're changing where this stop is sitting, which what the slide valve is rest against.
Your discharge.
You load the machine, it's pulling the valve to suction. It'll make a little more sense when we get the rotors out and you can see where the valve itself sits. I can set this stuff back in there.
So that the primary slide is?
This is the stop. This is the slide stop. So
That's where it comes up again.
this is what the slide valve is going to stop against when the variable is set for what VI. This is what's stopping that. So something we look for on these is we're checking this edge right here. And like on this one, you can see there's somewhere where this valve is actually raised up and contacted the edge of these rotor tips. This one's not excessive. If you generally start feeling a lift where it carried it over, this one's very minor. We can clean a lot of that up. And again, this is on the slide stop itself. That rod should pull up. You can pull it all the way. I'm not even turning it anymore. There you go. You have your hands first. That one's stuck on. It's still stuck? Yeah.
That's the slide valve.
So this is the valve itself. So, valve itself is actually really good. Not a lot. Again,
That's nasty.
that's where you'll see where it's fitting. Rotors are turning this way, so it always carries the material over. On, this was a variable, so it doesn't have a guide block. The older Mycoms
Yeah, that one.
actually have a slot that's down in here on the fixed VIs that hold that valve from rocking one way or the other. This one's gonna rely more on the discharge head. Where this goes through, it doesn't actually come clear out of the discharge head. You know, getting the rotors out too. Yeah.
We're gonna. Just like, put down to the-
Yeah, you didn't do it, because it's got fitting on the bottom of it.
We go, that might have to move around, but.
Oh, we're gonna come to.
That's been on a machine, you tell its rotation, it doesn't have a rotation arrow.
So. If you're looking at the machine from the Irving side, the rotor's on the left, it's gonna spin. If it's on the right, it goes to the right. And that, again, it'll make more sense when we get these out, we can see. I'll put the valve back in and make it a little more sense. Things that I know generally, that's a note of myself. This machine's been rebuilt, kind of that. The factory Micon nameplate, it's got a blue gasket. That's an gasket, all of that, so. I usually am mindful, especially going. What do they do? If there's any machine we're always gonna be checking these surfaces up here, these journals, these bearings are right in. You want to make sure that these these can be repaired, it's not a major deal, but I did just have one in here not too long ago where this was metal sprayed. And the metal spray was coming off. And we only found it, obviously, it wasn't visible until we're cleaning it and you could see it looked like a fracture. And at that point, I'm not gonna just send it out that way, I'm gonna investigate that fracture, and it turned out it is a metal spray. And at that point, correcting it, machine it back off and sleeve it.
How often do you get the service reports on a rebuild that, you've got in the shop that tells you that this rebuild's been done and this is what's done to it before?
A lot of times there's rebuild tags on them, whether it's from us or other manufacturers. If it's from us, it generally, for whatever reason, you seem to remember them, especially troubled compressors. Again, where knowing somebody's been in here, you're just mindful of looking at the common components that have excessive wear normally or whatever. They've been repaired. Has there been any repairs done? The end of these rotors have these are balance marks, these holes on the end, these are balancing the rotors. They come from the factory balanced. Any compressor we take apart, we balance the rotors. That affects the longevity of the thrust bearings. And you'd be surprised, even if this was balanced at the factory, it might have hit their spec. But once we have them, we take them in and have them rebalanced. They take it down as far as they can go without having to, you know, say they drilled the hole too far and now they got to start over because they got to fix something or, you know, adjust the weight one way versus the other.
So we do have the full.
Yeah, we always send a report after we're done rebuilding the machine. There's gonna be some pictures from this assembly.
Yeah, I'm setting up my schema.
This valve was contacting. the
Right.
rotor.
I wanna know service records in every asset. What do we do to this piece of
Pictures of
equipment,
that.
right? And make sure that if we do have to send it out for repair, I provide all that to the shop, whether it's you or Apco or. Whatever. So, those are-
And then
So, well spray repairs and, having. What type?
See it?
Well, I'm saying that with 50.
Just seeing it.
Then I can show how we can use the fifteen mile radius.
You got room over there?
Yeah, I can do some. Do that 4-foot strap.
Right, right, no,
Any gloves?
we've had more problems with the bin motors and, and that's a
We got the
micron
3/4
problem,
here and
not a compressor plant. Yeah, they're 600 horsepower, I can't. Yeah, there's a wedge motor, yeah, and it's WEG, and Micron contracted with WEG, so they're the only ones who make that motor, not anyone else. I'd much rather have a Toshiba 841 there, but that's the way it is. It,
4160.
yeah.
Oh, yeah, you do have enough.
No, 480.
Oh, yeah. Okay. So you make retrofits. Alright.
What?
Yeah, maybe I need to.
No, my motor, that story, that frame, that style motor, they got to deal with Micron, and get to everything else.
Yep. So we, obviously, all of us. Experience problems with lag.
But now that's the little. I think you want to be very mindful that you're.
Steel toe shoes.
Absolutely.
See there,
Ah.
the extra compression section is really not very. That's it.
So what do we want?
I got one 500 that, or that's 12 years old, and I got two.
So on the rotors themselves, these ones are actually in fairly
About
good
8
shape.
years old. I got one.
Um, We're mainly looking right here and down the valley. That's where the, compressing, so these areas seal with film oil in the rotor housing itself. Like I said, both of these are in really good shape. It's not uncommon to see these with a lot of scarring and stuff on them. So this area right here is critical.
Well, give me a.
This is where
give me
your
a business
clearance
card
is
and
set
put
off
Nick's
that
number
head
up the
back
back
there.
before I leave.
You
I
can
didn't bring
see
any of it.
down here.
But you send me an email.
Scratch mark around the heel.
Yeah.
But that's gonna be
Always
from,
interested in-
some sort of debris contamination that's done that. When you're talking like a machine this size probably runs at a clearance around 2,500. So that's not a lot. If you get anything back here,
I had with Apco.
it's
Just
gonna tend to scratch that stuff up.
So it was kind of funny that.
So where would the discharge documentation be?
That would be in the situation. And you'll always see this, that scratched up into this. And that's, if it's on the suction side, it's not so critical because it's on the suction, if this gets damaged, we'll usually face it off, clean it up. depending on how damaged the suction head is, you have to have one hairline fraction, so we can in this area.
490? Yeah.
Anywhere along in here, especially on the side, you gotta watch those.
Okay, some of yours too.
It's on the suction side, all the compression's done on the other end. So, I wonder if we can. You can set this down somewhere. I'll set the valve back in with the male rotor so you guys can kind of see how the slide valve works.
So when you get this, yeah, we will. Yeah, we will. Yep. Yeah, always. What am I doing? You got more diapers? Yeah, I don't know. There's diet here, right? You're going down or? Getting over the. Oh, okay. Where you gonna roll this?
Depending on the bench.
Wife, where you going?
Yeah. Correct, they are constant. There's timing marks. On the male, it's gonna be down in the valley. On the female lobe, it's gonna be on the lobe. I have seen them come in where they weren't. I'm sending them out time. I'm not saying there's any issue, but basically, in their time, it's if there's any sort of defect that's happened, okay, it shoots something up at some point. It's gonna hit some spot everything. Bricks on the other hand, every manufacturer will do different beginning like these and stuff. They might not be trying. Bricks are as well. You don't understand.
I see your email.
It's clearance is less super tight. So you can see right here, this is how tight the clearances are. That's how close that rotor rides.
What is that? 10,000?
I don't have the exact number. It runs on an oil, so it's very tight. So if this machine's unloaded, that valve's gonna be back there. When that happens, there's a gap. It's right here, so you can see that's where the slide stops. We always pay attention to the witnesses on the VIs when they come in. So we set them back where they were. And then, so basically, as you load that machine, it's gonna close that gap off. But when it does that, it seals off this area down here, which in turn makes the gas get compressed.
We should get that camera over here to do that. I assume that the recording will be available.
Yeah.
Excellent. I got two guys in one. Make sure that they get.
So you can see that port in the very back of this is very small, as that machine is fully loaded. When it's unloaded, you think that gap's full right there, but the gas is bypassing right here, so it's not fully compressing. And then as it loads, seals off that chamber, now it's compressed and it's forced out that small hole in the back.
So this comes back out to suction again,
This moves to suction.
but the rest of the gas that isn't getting compressed.
It's
comes
sealed
back-
now.
Okay,
So if you look at this rotor housing, you can see a gap right here. That's where the gas is coming in. Forced, as it turns, it's pulling it in.
okay.
So then as it's sealed back here, again, oil film, it hits its compression down here in the very back, and that's where it's released. On these ports you see on the side, this is gonna be for oil coming in to lubricate and cool everything.
So fully unloaded, it's all the way in.
Fully unloaded, it's, yeah,
All the way
correct,
in.
it's going toward discharge.
Towards the discharge.
You can really see the valves and everything open up in here. You come over to the side.
Yeah, basically I'm referring to when it's in bypass, you see these areas are open. So you're getting suction. That's just relieving the pressure and it goes back. And then as it loads, it seals those off. So on a lot of these, especially the slide valve bricks, it's a lot more common. You're always checking the slide valve rock, which would be moving this valve back and forth. And what it does, this valve doesn't fully disengage out of the discharge head. There's that little bit right here on the end that stays in place that keeps that valve from rolling. And in this case, I don't really see a particular reason to pull the nail all the way out. But just to show you guys, this is where that clearance is set that we were talking about on the other side with the thrust bearing spacer. And that's the critical end of it. So say this machine's running, you know, 2000s clearance back there, and now your bearings start to fail. You run the risk of that machine contacting. And that's what you try to avoid. That's when you end up with, you know, major repairs, could wreck the machine, stuff like that. So,
We have a wrecked machine.
yeah,
That's why we check and play every time we do a level inspection.
right. That's what you're trying to catch. You're trying to catch that play in the bearing. There's nothing, like I said, some bearings last 5-10 years. You never know. It's how many starts and stops does it have? How clean's the oil?
So how effective is vibration analysis as a predictive maintenance measure on finding when you're starting to have work?
It should catch it pretty fast. As
So
long as it's done
even,
and clean.
even if you're only having a base, it's non-calibrated equipment and you're only having a
Right.
baseline and you, all of a sudden you see something, you know,
You're
your
trending,
wife
what
or
it
your
was.
friends bring up, you know, and get
Basically,
someone in to look at it, right?
When you're doing that, you might see, you know, the amplitude changing, velocity, that kind of stuff, and that's what they're looking for. Basically, you want that machine fully loaded when you're checking that. That's when everything's ideal. That's when you want it done.
So I imagine we got a lot of techs here, right, tonight, or, you know, from the industry, and you have a couple of you. How many of you are doing vibration analysis in your compressors right now?
We do.
No, I mean, seriously, raise your hand on that. Out of all of us, how many? Because I'm not, I want to, but I'm telling management we need to do it, and so.
Are you on
Are you
DSM?
guys, right?
DSM should be.
Oh, so you guys are, you know, so you have. SCADA system already, okay.
Most of the plants that we service are doing vibration analysis annually. And quite a few of them were doing them. Some of them they do them themselves or they have a third party do them. But we run about 85 clients in this area. I would say 90% of them are doing vibration analysis and oil samples on a regular basis.
On an annual basis.
On an annual basis.
So,
Oil samples
so how about a monthly basis on vibration?
So that could be quite expensive. However, if you have onboard vibration analysis, that's different. Okay?
We do have customers that do biannual too.
Yeah, twice a year on,
Twice a year.
but once a month, that could get pretty expensive.
Unless you're doing it yourself,
Yeah,
right? You mean, like I said, a non-collaborative fluke, which is like, you know, $5,000, you know, and someone who knows how to use it and is taking a horizontal and a
that's
vertical, not so
the
much.
problem is getting the right guy to read the results.
Right.
And it's not just reading them, it's putting the accelerometer on correctly.
Yeah,
And
everything.
if you take that accelerometer and you go, when it's stable and you pull a reading, you bring that accelerometer, and it's,
Right.
you're gonna have to wait till it brings down to get an accurate reading.
Okay.
So it's about the technician that takes the analysis, and it's about the guy that reads it.
Right.
Depending how loaded your compressor is.
All of that matters.
Yeah, and if you're, especially if you're doing vibration analysis annually, biannually, it doesn't matter, you want the same condition every time. Cause you're basically trying to establish a trend. So if you start a baseline and you're doing it 100%, the next time the guy goes back into 40%. They're gonna flag it as it's got a gas flow. Which, you know, that can amount to.
What I wanna know is if we make a change in our process, how we're defrosting and all of a sudden I got a compressor that's starting and stopping, you know, 12 times a shift. You know, because we made a change in our process, what's it doing to that machine? That's why I'm pushing for, you know, at least a baseline monthly readings, you know.
So one of the things that we do on our rebuilds part of the rebuild is vibration analysis. So you get a baseline when we're done. We fire up the machine, that's part of the startup report, you get a baseline of what's going on.
Alignment. and
So-
Vibration goal, yeah.
6 months later, when you do it again, you know already where it started and where it's.
Yeah, I wanna catch it before it gets there, right? Of course, we make a change in our process a month after we have our annual done.
Yep.
I got 11 months of that machine, possibly operating in, critical speed where it shouldn't be, or whatever the situation is, to say, let's tune that out of our refrigeration controls, so we're not.
So other things.
Like you were saying, oil contamination, whatever else that, okay, it starts and stops, he said starts and stops, that's the thing.
Other things that we see is improper lubrication of motors. People aren't lubricating motors properly, or they're mixing grease, and it's a serious problem. Or they're using the powered grease gun.
Too much is just as bad as not enough.
Yep, powered grease gun's hot.
All right, so you gotta take it apart and put it together.
I think we'll put it in a box tomorrow and it's going home.
So that's the stop.
This is the stop, that's the actual valve. So this isn't in, you won't see this as secondary and primary as far as secondary. I think what you're referring to would be like a secondary being the slide. Okay. So that, a lot of people get confused with that. Yeah, I know. This right here, this correlates with your VI.
This is what I want.
So if you're running at a really high VI, that machine, that valve is not gonna move. If it's high VI, that valve moves. When it's a low VI, it's, yeah, it's actually gonna be a big.
Do it.
So this way we have a VI.
There's a nut that goes on and so many turns.
So that could be a variable or in the case.
So
That's right here.
That's where it's calibrated. They're gonna use-
are variable.
Say we rebuild the machine, it goes back on.
Control the set, so this one, hydraulic, this one,
Calibrate the side
you
stop,
set it,
calibrate the slide. And then.
but there are
operators
that you are built by the factory and you can change it.
In this particular case, it's not generally, you're not gonna. mess with what it says. This would be a quick. This is the manual variable, it's set, and then you don't touch it. So the older Micron, it's VI, all that stuff.
Yes.
The size of that board in the back. So we get a
It
boost.
only allows it to
That
come
hole
so
is
far,
twice as high.
because then you'll overcompress.
So basically, yeah, you have a hole this big and it compresses. a lot. Well, if that hole's this big, it can't compress that much. So you're getting volume, you're not getting.
Well, the mill rotor right here, that's low load.
Is that standard for all? No, that shouldn't standard.
Okay.
Yeah, you'll see, sometimes.
How does that affect that compression ratio there?
I think it confuses. Every manufacturer has their own.
Yeah, so I know I watched the video on the right side of it, talking about the black, it's a secondary slot.
Yeah, that's what.
So would that be considered a VI valve? So VI valve, right?
Yeah, so that valve is a valve. So this one moves manually. That's what moves it.
And like even your needle at the end,
Or brake, the hydraulic. By the hour, there'd be pistons in there.
Oh, so the way I think about it is, I'm not using.
You're what? Sorry.
I'm not using.
Anybody needs hours?
I got a high sharp.
Yeah. Get hours when you read a credit.
8 miles. He's 72.
I don't know where the bit was.
So it'll go from 2.2 to 5.0.
I'm sorry, see the check. If you're looking. No, yeah. Hey, appreciate it, thank you guys. Looks like it's wrapping up, I'm gonna let it go for probably another 4 minutes, and I'll close it up at 7:30.
This is where.
You guys need an hour, go ahead and send an email.
Okay,
Cause I teach this, but I've never seen it. So.
so like this machine. Say
Send an email stating your name, and then, I'll be able to get that signed off for you and send it back. It might take me a day or two, probably won't get it until Saturday, but go ahead and send that
So if we're.
over to that email.
That slide spot's gonna be moved out here, and you see how big that hole is.
Usually the rest of you do
It's, you're not compressing it.
you're not compressing it. Yes.
You know how?
So again, you see how when.
They have
one
online,
small,
they have online
you're
stuff.
compressing that gas a lot further. With that valve.
Yeah, if you take all three or one, that's like 24.
That's generally about the idea.
I'm using more.
Naturally,
Yeah.
right?
Right.
That stops it, we gotta hear them.
Stop it.
So for us, we do our subway changes on the suction side.
They have studies. Then they have one and two tests.
You don't need it.
Because we don't need as much of the machine.
And.
Well, right.
That fixed the eye mic. The valve, it's not gonna have to stop. It's just gonna slide. Where they make the change is the fixed VI stays with the low VI. This whole thing is gonna be different configuration than this. But make that whole bigger. On a high VI machine, it would be about 70 hours to go. And the valve would be. 70 hours to go. Yeah, like side of it. And that's where you're gonna see that whole.
Right now.
And again, this one is a very, it's manually set by that.
Well, for me, it's 2 hours.
Set for this set.
3 to 2.
And that determines how far that valve.
One more.
1.5.
On the sliding side. If this is set way back, right? So now,
70.
yeah.
What we're doing right now. I was gonna put a.
Would you take that?
Huh?
Right there. you're-
Oh, you gotta submit.
This will be. You're right in the middle. Down here, the suction is still coming. Right, so it's bypassing, yeah, it's not compressing. It's not sealed right now, so it's.
Yeah, I think I just take a picture of it right now.
Okay, so you go ahead and set this VI so you make it a whole machine.
24 hours.
No. So, actually, with the VI, less than.
Basically, the rod's gonna. So this hydraulically, that's what it's doing.
So now it's so back to your 100%. Is it still 100%?
Read it, guys, they'll send it.
But still, we have very.
So right now you're all.
Yeah, they're doing the same.
on Zoom?
This stuff's gonna move hydraulics. The process-
They send an email out.
Stay the same. Okay, it's, yeah, all right, that's confusing, that confuses me, how can it be the same as that making?
Start getting them more.
Because it knows it's a VI loop. There's a correlation between the two, so it knows, hey,
Alright, I got you, man, I'll get to, it might take me a couple days, but I'll get it going.
so when we switch it to this VI, we now know that this really.
That was always confusing, how does the machine know?
And a common question.
Like from.
Rolling magazine.
You should.
I'll sign up.
Like on
Say,
a
wait,
machine like
thought
this,
we
you
did
should
a couple
change
times,
it.
so we were in
And we ran into,
They did it.
you know, hey, I looked at the book and it said.
Those says you're gonna be close to one individual for the next.
I'm wearing this. I didn't know where it said. And
Now they, a lot
the
of.
book tells you I need it. That's it. You always can run it all the way in. And then it's like 12 and a quarter turns.
You change the suction set.
Now, I'm on my.
The VI
Right. And.
I couldn't tell, but when Mr. Gold came, he was changing.
Not a problem.
All he put his hand is down.
No, I've been there.
He needs to have it set at 12 and a quarter turns.
I wanna do, my take on it, Mr. Gary, position.
It's a turn. Either compressor is over compressor or is under compressor. Either way.